And then, are there any questions on the homework?
Nope.
I had a hard time on 9 and 10. Like, I didn't really understand or remember how you explained those.
Okay. All right. So number 9 and 10, you said?
Yeah.
All right. So Annabelle, I'm not going to answer it right away right now. I'm going to kind of teach what I was going to teach because yours go right into what I felt like we need more practice on.
Okay, perfect.
All right. So first off, you need to understand there's two directions, right? Like I think that if I asked you to describe the end behavior of this graph, most of you could do that. I believe most of you could say the left side of the graph is going down and the right side of the graph is going up. Is there anyone who like thinks that that's just, I don't understand what you're talking about? Does everybody feel like they can do that?
Yeah.
And what I showed you yesterday was you would maybe make something like this. And this would symbolize the left side of the graph is going down, the right side of the graph is going up. Well, we can't say that necessarily mathematically. That's not really that's not good math language. It's good for us. It's make sure that that's what I want to start out with to make sure we understand what's going on. But a better way of saying that is actually using math terms. So let's talk about this for a second. We're going to connect these two thoughts together. What happens as I travel on this x-axis? First off, everybody understands this is x and this is y. And x travels left and right. So this is the traveling right. And this is where my x is traveling left. But as I keep going, what happens? Why do I put arrowheads on this? Why do I get, when I get here, why do I put arrowheads here and here?
To indicate it's still going.
And what is it going on to, Daniel?
Forever.
And the way that we say that is in math, we call it positive infinity. So if I said x is traveling to positive infinity, what am I really saying in English?
It's ending in positive.
If I say x is traveling right, or I'm saying, sorry, I gave you the answer. If I said x is traveling towards positive infinity, what I'm really telling you is I'm going right. I'm talking about the right side of the equation or of the graph. Does that make sense?
So for number 8, we would have wrote right or positive infinity.
I'll get there.
Okay, sorry, I just don't understand.
No. I'll get where we're, but this is math, or this is English. This is math. They both kind of are the same thing. For my class, I'll probably take either, but like if you're on the SATs or let's say it's multiple choice, you need to know, maybe this language. Do you get what I mean by that now, Annabella?
Yeah.
Okay. How could I say I'm going left on a graph? I could say I'm going left or the left side of the graph, or what else? What is x going towards?
Negative infinity.
Now, what's the difference between this positive infinity? What's the difference between this positive infinity and this positive infinity?
That one's up and that one's right.
So this one is in a total different direction. This is traveling up and down, aka the y. And the difference between this negative infinity and this negative infinity is this one is going down. So if I had a graph like this, like you did last night on your homework, and someone asks you to describe the end behavior, hopefully you understand left side of the graph is traveling up. Well, a better way to say that mathematically is as x approaches. How do I say left mathematically?
Negative infinity.
As x approaches negative infinity, that means left. Y goes to, because it's a different variable, what is y going to? Well, what direction is this arrowhead facing? Up.
Right or up, yeah.
How do I say that using math? What's up? What's the direction of up on the y?
Positive infinity.
Annabella, does that make sense?
Yeah, I forget how to like write it in that order. Like I've seen you write it like that before.
But do you see how I'm making it? Hopefully you're understanding what I'm talking about. When you say left, that's this side, that's negative infinity side.
Okay.
When you say right, that's the positive infinity side of the x. Because left and right are x. Up and down are the y. So try the next one for me. As x approaches, I'm talking about this side now. Annabelle?
Sorry, I was gonna write it, but it is positive infinity.
Yes, that means the right side of the graph. What you just told me is the right side.
But it's still going to positive infinity.
The y is going to positive infinity. That's fine for this. Both ends are going what?
Up or positive.
Yeah, both ends are going up. That's okay. Both ends are going to the same direction. This says the left goes up. This says the right also goes up, which is totally fine. Does that make sense?
Yes.
Are there any questions on what I just said to describe end behavior?
No.
This is the way that it's probably going to be written on the test. All right, so try this one on your own. Describe that end behavior. Be ready because I might call on you. All right, Austin. Austin, can you unmute for me, bud?
Yeah.
All right, help me describe this end behavior. So I'll help you out in the beginning. As X, what is X going to?
That's not the minimum, is it? No.
Did you just pay attention to what I went over or no? Just be honest.
No.
Okay.
Sorry.
It's all right. You might want to watch the beginning of this video. Destiny.
Yeah.
What is, as X, what is the X going towards?
Negative infinity.
Why is it going to negative infinity?
Going down.
No.
Oh, it's going to the left.
Yes, because X is left and right.
Yeah.
So I'm talking about the left side of the graph because I'm over here. So it's negative infinity. And yes, now which way is it going? So as X goes to negative infinity, so AKA the left side of the graph, where is Y going to?
It's going to negative infinity.
Yes. Now I'm going to talk about this side of the graph. So now as X goes to what?
Infinity.
Good. Or positive infinity. Yep. Positive infinity, infinity. Y is going to what?
Positive infinity.
Perfect. That would be your answer for this one. Does everybody see how I'm talking about with the infinity signs on which way it's going? The X is the left and right. See how it's on the left side, so I use the negative. It's going down, so I use the negative. It's on the right side, so I use the positive infinity. Because it's going up, I use positive infinity here as well. All right. A couple other things that we need to talk about. This is still based on that graph that you kind of did last night. I'm assuming that everybody has understands money. And what happens if I'm on this line? Let's assume that these are weeks, and I know it's weird. This is a negative week, but whatever. This is -4 weeks, -2 weeks, 1 and 3. What happened at each one of those weeks? This is my sales for the week. This graph represents how much money I made. What happened at each one of those weeks?
They came in at a different X.
They lost or gained money?
So this is not a running total. So what I mean by that is at this week, that's how much money I made. So let's say I made $200. The next week, I made only $150. What happened at week -4?
I don't know.
You spent?
What is this order? What is this ordered pair right here, guys?
0, -4, or -4, 0.
So -4 represents the week. What does the 0 represent?
Where you're at the whole time?
Money.
My money. How much money did I make on week -4?
0.
How much money did I make at -0? How much money did I make week 1?
0.
How much money did I make on week 3?
0.
Does that make sense?
Yeah.
Anytime I am on this axis, my y is guaranteed to be 0. This whole line is called y = 0. And if it was like money or something, that would mean I made no money on those weeks. I didn't lose money, but I didn't make any money. what does that mean for all of these weeks? All of these outputs, what does that guarantee me then? Why did I do it in green?
Because you gain money then.
Now look, did I gain more money here than I did here?
Mm-hmm.
Am I talking about that though? No. My question to you is, where did I gain money? It doesn't matter if I only gained a penny. If I gained money, I gained money. Where were all of the areas of this graph where I gained money be at? Isabella?
Yes.
Where will all the spots on this graph be where I gained money?
Right around. Right around -2 and 1.
So between -2 and 1, you're saying this area right here?
Yes.
Yep, all that spot I gained money. Where else?
And near 3.
Anything after 3? Not 3 though, not week 3. Why not at week 3? How much money did I make on week 3?
I'm not sure.
Okay, what's the ordered pair for week 3? Stay unmuted for me. What's the ordered pair for this?
I'm not sure.
Do you know about the X and Y axis? Do you know any like that kind of stuff?
I think so. Sure.
So you remember you read the X and Y. So like if I was at this ordered pair, I would count how far I go over and then how far I go up, and that would be this. So this ordered pair would be 2, 2, right? Because I went over 2 and up 2, right?
Yeah.
So if I'm on this dot, what did I do to get there?
You went over 3.
And up what?
Up 1.
No. I didn't go up at all.
Up 0.
Right. So what's the ordered pair? Isabella?
0 and 3.
No. Order matters here. You go left and right first, then up and down.
Okay, so 3, 0.
And that matters big time. That's some of the stuff that, so if we're not understanding how to do that, then graphing is going to be a big issue. Okay.
Yeah.
So this is 3, 0. That means on week 3, how much money did I get? 0. It means I didn't lose any money. It didn't means I didn't gain anything. So on week 3, I can't say that I gained money. It would be anything after week 3 I gained money. Is that making sense?
Yeah.
Do you see everything that's in the green would be spots? Now, what is confusing is, like I said, some kids think, well, wait, from here to here, you didn't get as much money, meaning I made more money in this week than I did this week. Hopefully you can see that, which is true, but I don't care. When I asked the question, I said, where did I gain money? All I care about is that the graph piece has to be what? Look at the location of all the greens. Where are they located?
Above 0.
Close.
Above the x-axis.
Why can't you just say above 0? How many different things do I have on the graph? How many different directions do I have in the graph? Callie?
Sorry, a little bit. There's 4 different directions you can go: up, down, left, and right.
We count left and right really the same. So you were right the first time. There's really two directionals you can do. Left and right, we call it horizontal. So you can travel horizontally or vertically. Does that make sense?
Yeah, that makes perfect sense.
So how come I can't say above the 0?
Because we're talking about
What is this line right here, guys?
vertical.
It's also a 0. What equals 0 on that line? You haven't gone anything left or right. Your x equals 0. So you can't say it's above the 0 line because there's 2 0 lines. What is this purple line that we're referring to called?
Would you say it's above the y-axis or the x-axis?
Okay, so you're correct on the second one. It is the line of y equals 0, and we refer to that as the x-axis. The y-axis is the one that's the yellow, and that's where x equals 0, because you haven't gone left or right. So if I want to know where the graph is going to be positive, what I've told you when I say I want my graph to be positive, I have really told you I want to know what pieces is the y positive. That's the question. When I say the graph is positive, or I want to know the positive section, I'm saying where on this are the pieces where my y are positive. Well, if this right here, if this purple line is the spot where y is 0, then anything above it is going to be positive. So that's this green section, that's this green section, and that's this green section. Now, how I say that is, what do I know about all the numbers? Because I want from here over, right? If I want anything, you use any of these x's, if you use any of those x's, I'm guaranteeing your y that's going to come out is positive. Because if you go this way, you have to go up to get to the graph. So how do I tell them if you use this x? Well, I could say in words, hey, if you use anything less than 4, negative 4, right? So the way we say that mathematically is x has to be less than negative 4. If you use anything less than 4, what am I guaranteeing you, Mr. Martin? Your y will be positive. If you use anything between negative 2 and 1, the way we write that is between negative 2 and 1. What are you guaranteeing me? The y will be positive. And finally, if you use anything where your x is greater than 3, anything bigger than 3, I'm guaranteeing your y could be positive. How come it can't be equal to? Because at 3, my y is 0, which is not positive. I want my y to be positive. Does that make sense?
Yeah.
Okay. I'm giving you a chance to ask because I'm about to switch it now. Tucker, where is my y negative? What would have to happen if I want I said, where is this graph negative? Where would you be looking, Tucker?
On the x-axis.
What do you mean? No. On the x-axis, it's 0. Think, Tucker.
Isn't that what you just asked?
No, I said, where is it negative?
Oh, underneath the x-axis.
And so that would be this part that I'm putting in red now. All of these sections of this graph are negative. Does that make sense?
Yep.
Janina, how would I tell the person for this section? How would I tell them? And just tell me in English.
Between negative 4 and negative 3, the graph will be negative.
Negative 2. But you're good, yes.
Sorry.
So it'd be between -4.
Why did he say it in English?
Because in math, whoever's talking behind you, we would say x -4 is less than x, which is less than -2, which is kind of speaking math.
Yeah, sorry, that was my sister.
No, she's fine. I'll teach her too. I don't care. So in math, we would write it like this, which is saying between -4 and -2. So how do we say the next section?
Between 1 and 3, the graph will be negative.
And so how would we say that in math?
1 is less than x, and x is less than 3.
Just like that. So 1 is less than x, which is less than 3. Perfect. If I look at any of those spaces, what can you guarantee me? If you use an x between -2 or -4 and -2 and 1 and 3, Austin, what can you guarantee me? Perfect. Daniel, what can you guarantee me? If you use one of these x's, what can you guarantee me is going to be true of your y? Orist, are you there?
Yes.
If you use a number between -4 and -2, or at x between 1 and 3, what can you guarantee me your y is going to be?
Well, let me see. Negative?
Yes, because everywhere on here, if I'm between -4 and -2, all these values are below the x-axis, which is all my y's are negative down here. You had to go down to get to these, to the graph. That's what I'm looking for. Now, that's when they ask you for if they say when the graph is positive, when the graph is negative, that's what they're asking you for. What x's will give you y's that are negative, and what x's will give you positive. And so these are the answer for the -1. Now, don't get that confused. Same type of graph, very similar, with this, where I say, where is this graph? Where is this graph decreasing? And so the way I look at decreasing is I'd look at from left to right. What is this graph doing? It's pretend like it's a movie, right? What is this story doing? Is this character having a good thing happening in their life, or is bad things happening? Destiny? Are good things happening in this character's life right now, or bad? The purple.
Good things?
Left to right, Destiny.
No, bad things.
Bad things, because what's happening to my graph? It's doing what from left to right?
It's going down.
Right, so that would be decreasing. From left to right, it's decreasing. And then all of a sudden I get to right here, and yesterday, what did I call that?
Something to do with minimum.
No, you're right. So this is it's an absolute minimum because there is no other lowest point. This is right here the lowest it gets in their life. There is another low point, but this point is lower than this one. So this is an absolute, whereas this is called what we call a relative minimum. But we also call those turning points. Why do we call those turning points? What's going to happen to this character's life now?
It's going to go back up.
Which means good things are happening to them. That's why this point right here is called a turning point, because things are now getting better for them in the movie. We are following them along, and then all of a sudden, oh no, bad things happen again. Their puppy passed away, and now bad things are happening. They lost their job, they lost their girlfriend, and then all of a sudden, they find this special character in their life that is now turning things around. And finally, they live happily ever after, and forever they go on into happiness. Right? I know it's a terrible movie. That's why I'm a teacher. But this is talking about decreasing. Everything in purple is the spot where it's decreasing. Everything in yellow is the spot that it's increasing. And I'm telling you about the y, right? From here to here, what are my y's doing? Well, this is a negative y. This is a positive y. From the yellow, all the y's are now going up from here to here. That's an increase, yes?
Yeah.
So you would tell me the x's. It would be like you saying, I want to go, hey, I don't like watching the sad parts of the movie. So can you just tell me what parts I should watch? I just want to watch the good parts. And you'd be like, hey, you want to watch between here and here. If you watch this section of the movie, I'll guarantee you it's all happy. And then fast forward until you get to this section and you can watch the rest of the movie because it's all happy from then on. So you would tell me to watch this section of the movie and from here on. And then you're guaranteeing me to watch the good parts. So you would have to tell me what x is. So let's say that this is a -3 and this is a -1. You would say, Mr. Martin, if you watch between -3 and -1 for your x, if you use those x's, meaning -3, if you use -3 as less than x and less than 1, -1, I'm guaranteed if you watch that section of movie, you're going to see only happy things. Or Mr. Martin, if you watch from x being greater than 2, if you watch from this part on, I'm guaranteeing you good things.
Right.
You want to watch the bad things, Mr. Martin? You're going to watch from x being less than -2, or less than -3, sorry. Or between -1 and 2. That's where all the bad stuff happens. That's what you're describing when someone says for positive, or I'm sorry, for increasing and decreasing. Again, the change happens at what we call turning points or minimums and maximums. Where did this change from being positive to being negative at?
I don't know.
You don't know what these points are called right here?
The x-intercepts.
They're called x-intercepts. Yeah. So at the x-intercepts, graphs change from positive to negative. At turning points, we have decreases changing to increases. And finally, what you need to know for homework. So that should be a recap of everything that we've kind of already talked about. Finally, for homework, you're going to have to do a average rate of change. And from here, like when you did rate of change, when you first heard that term, you were only dealing with linear. And what happens is from here to here and here to here, you go up and over. Well, you go up and over the same amount. The rate of change never changes because it's linear. It's always the same. That's what makes it linear. Well, when we're dealing with our graphs, we can't get a rate of change because a rate of change is different, right? Between here and here, they're experiencing really good luck. Things are really happening. From here to here, some good things are happening. They're moving forward, but not as a big drastic deep, thing. From here to here, now bad things are happening. So the rate of change completely is different. This is a positive rate of change, a little positive rate of change, a bad, drastic, negative rate of change. So what we do is we call it the average rate of change. We said, hey, from this point to this point, and what we do is we just calculate the rate of change between these two directly. So if I said, what's the average rate of change between -4 and -1? The problem is when I say that the interval, if I say the interval of -4 to -1, both of these values are x values. That is the -4 here. That is the -1 here. The problem with rate of change is I need a y minus y over x minus x, and I only have x values. So what I have to do is I have to go back to my graph and I have to look at it and I go, okay, what is this ordered pair? And when I look at it, it looks like it's -4, 3. And when I look at this one, we'll call this -1, -1. So this over here is not an ordered pair. It's the x of the first point that I'm going to use, and it's the x of the second point I'm going to use. I actually have to use the graph to find the y. Then I do my y minus y over x minus x. So this would turn into 3 minus a -1 over -4 minus a -1, which would turn into a 4 over -3. So -4/3 would be my average rate of change between these 2 points. Does anyone have questions on average rate of change?
It's basically the slope.
It is the slope, but we call it, like I said, we call it an average rate of, it is the slope.
But it's for like a squiggly line one.
Right, but we can't find, like, I can't find a slope here because it, like I said, this slope right here between these 2 points
It's
is
curved.
different than these 2 points. And it is a curve, right? It's not the same. It's not consistent. That's why it's a curve, right? So we do call it the average rate of change. And what we do is we say, well, if I look at it from here to here, yes, the person went really high, but then they also had a really low. But overall, they had a good experience, right? There's a positive rate of change here because from here to here, I still ended up. Now, if we kept going, we would say, oh, that from here to here, there's a negative average rate of change. If I went from here to here, there would again be a positive. So it depends on where you're starting and where your ending is, because you're looking at only this section. From here to here, their life had a positive outlook. Does that make sense, Annabella?
Yes, thank you.
It's kind of like looking at our days, you know? Like, oh, today's doing well. Oh, crap, there's the bad part. Oh, there's another good part, bad part. And then, okay, it ended like this. Like, overall, you know, I started here, I ended here. On average, I had a good day. There were some parts that went, you know, a little bit down. There were other great parts. And then, you know, but overall, that's kind of like what it's doing. Average rate of change overall from here to here. And then, so it's like you're connecting these 2 points just directly, and you're calculating the slope between them. You're not going through all the ups and downs, if that makes sense. All right.